Alright, the first thing you want to do is put your data in L1 and L2. So you're going to put all the MRI scores in L1 as one big list of 10, and then all the IQ scores in L2 as one big list of 10. Then you're going to go to second y equals. You're going to choose the stat plot, and you'll hit zoom option 9 to see your scatter plot. You should see that plot roughly. For part B, you're going to compute the linear correlation coefficient R. So make sure you have your diagnostics on. Then stat calc option 4 or 8, either way. I usually use 4. That should give you your R value, the last entry, 0.801165. So that's where we're getting this. In order to answer yes or no, you're going to go down to your chart or click on the pop-up. Mine's at the bottom of the page. I'm going to go to this critical value chart. The sample size for both males and females together is 10. So we look on 10 on the chart. We see the critical value is 0.632. We compare what we got to 0.632. If what we got is greater, then a linear relationship exists. If it's less, then it does not. So that's how we know to answer yes to part B, that our correlation coefficient is bigger than the critical value. Then I want you to separate males and females. And so it's kind of clear that the female scores are lower and the male scores are higher, so it's pretty easy to choose that scatter plot. To get the linear correlation coefficient just for females, you want to delete all the male entries, the second 5, and run it again, StatCalc 4, to get the R value just for females. Then for males, you want to delete those female scores, put in just the male scores, and that gives you, again, the R value just for males. And that's where those two numbers came from. Same operation as before, StatCalc 4 with diagnostics on. And then here, we're going to compare. Now this time our sample size is only 5 because we have 5 females and 5 males. So we're going to look just for the females. It's a positive value. The absolute value of the correlation coefficient is the number you got up here, 0.827. You have to compare that to the critical value. So it says it's not greater than. Let's look at our chart again. This time we're using a sample size of 5. Oops. So with that sample size of 5, we're comparing it to 0.878. And the value we got is not greater than that. So the critical value is higher than our R value, which means that we don't have that linear relation for the females. If we look at the male R value, it is positive. The absolute value of that correlation coefficient is the same value we got above. Again, it's not greater than that critical value, that same number, 0.878. So those two numbers come from the chart with the sample size of 5. Because it's not greater, then no linear relationship exists between MRI and IQ for males. And that brings us to the summary statement. Even though it's positively linearly related for the whole population, if we separate by gender, it is not related individually by gender, just together as a whole.